so all of this, so even though there was 3 sets of notes, and then the word problem notes, 4 sets of notes, all 4 sets of notes are based on the basic SOHCAHTOA. Okay, so that's the biggest thing to get down, is to understand that sine is opposite over ooh. Oh, okay, it came back up. My whole screen just went down and everything went blank, but then it came back up. So I don't know if it went blank for you, but it went blank for me. All right, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay. So it completely depends on which angle you're looking at. So let's say I knew that this side was 4 and this side was 10. And I'm going to call this angle A and angle B. Well, looking at angle A, oops, I guess a couple of people did get kicked out. So if I'm looking at angle A, if I go straight out from angle A, I hit the 4. That means the 4 is the opposite leg, and then the 10 is the hypotenuse, because the hypotenuse is always across from the right angle. So that would be opposite and hypotenuse, so that would be sine. So here I would say the sine of A equals 4 over 10. Where if I was looking at angle B, well, the 4 for angle B is the adjacent leg, but the 10 is still the hypotenuse. So cosine is adjacent over hypotenuse. So the cosine of B is 4 over 10. So it completely depends on which angle you're looking at. Now, maybe I didn't know the hypotenuse. So let's say I actually had the 2 legs. So this is 6 and this is 11. So now looking at angle B or angle A, all right, 6 is the opposite leg. 11 is the adjacent leg. So tangent is opposite over adjacent. So the tangent of A is 6 over 11. But watch what happens when I switch angles. If I look at B, 11 is the opposite leg, and 6 is the adjacent leg. So the tangent of B is 11 over 6. Okay, so all of these really depend on which angle you're looking at. So that's what it really takes into account, is which angle am I looking at? Because for angle A, 6 is the opposite leg, but for angle B, 11 is the opposite leg. All right. So that just kind of goes over SOHCAHTOA. So let's do a few of these problems here. No one so far has said a specific problem, so I don't know, I'll just pick a couple here, and then I'll also do one of the ones where we're given the 2 sides. You're welcome. All right, so let's just start with like number 2. Okay, so I'm given that side A is 12. And I'm given that angle B is 53 degrees. Okay, so we can use anything we want. We can use SOHCAHTOA. We can use Pythagorean theorem. We can use the fact that the 3 angles have to add to 180, which means the acute angles have to add to 90. So we can, when we're solving the right triangle, you can use any information you have, anything. So if I'm given one angle, I'm just going to start with the other angle. The 2 acute angles have to add to 90. So angle A is going to be 37 degrees. Okay. So now I need to get to the sides. Well, I can't use Pythagorean theorem because 2 of the sides are missing. So I have to use SOHCAHTOA. And it doesn't matter which angle you use. You just pick which angle you're going to use, and then looking at that angle, do you have the opposite? Do you have the adjacent? That information. So since I was given angle B, looking at angle B, I need the opposite side. I have the adjacent. So that would be tangent. So tangent 53 equals B over 12 equals opposite leg over adjacent leg. And now, since we're actually solving for the side, we're going to use our calculator to evaluate this. So I'm going to multiply both sides by 12. So this is what I need to plug into my calculator. Okay. Most people who've been coming in have been telling me they're using the one on their cell phone. So that's the one I'm going to show. If you need help with other calculators, of course, come and see me and ask questions. So I need to do 12 times the tangent of 53. So I'm going to go 12 times 53 tangent. But that's just the tangent of 53. You have to hit the equal sign. That's where some people are finding out they forgot to hit the equal sign at the end. So they were doing it correctly, except that they just forgot to hit the equal sign. So equals 15.9. So B is 15.9. All right. So now we still need the hypotenuse. At this point in time, you could use Pythagorean theorem because you now have 2 of the 3 sides. I'm going to still use trig just because that's what we need to practice. Most of you are good with Pythagorean theorem. It's the trig that we need to understand and figure out. So I'm going to show it using trig. If you used Pythagorean theorem, that's perfectly fine. All right, so I still need C. So I'm just going to go back to this 53-degree angle. Looking at the 53-degree angle, I have the adjacent leg. I need the hypotenuse. Adjacent and hypotenuse, that is cosine. So cosine of 53 equals 12 over C. Now, this is one of those weird ones where the variable's in the denominator. So we have to first get the variable out of the denominator. So I'm going to multiply both sides by C. So I get C times the cosine of 53 equals 12. Then I'm going to divide by the cosine of 53. And so calculator, I now need to do this division. So I'm going to do 12 divided by 53 cosine. But again, that's just the cosine of 53. I have to hit equals to do the actual division. And so I get 19.9. So the hypotenuse is 19.9, almost 20. All right, and then now I have been asked to do number 3 and number 8. So we'll do those. All right, so number 3, let me make sure it's in my full screen there. There we go. All right, so angle B is 18 degrees. The hypotenuse is 24. So we need to find angle A and the 2 sides. All right, so again, to me, the easiest is the fact that if we have one angle, I just subtract that from 90. 90 minus 18 is 72 degrees. So obviously these are not drawn to scale. None of these are ever drawn to scale. You cannot tell me, but angle B is bigger than angle A. Yes, I know that, but they're not drawn to scale. Okay, so don't ever worry about that. All All right, so now to find the missing sides, I'm going to look for A first. So looking at the 18, A is the adjacent leg, 24 is the hypotenuse. So that would be cosine. So I'm going to say the cosine of 18 equals A over 24. Multiply both sides by 24. And here's our calculator. I need to do 24 times the cosine of 18. So 24 times 18 cosine, but again, that's the cosine of 18. I still have to hit equals to get 22.8.
There's a box of calculators over there if you guys want one. You know where they are?
Yeah, my calculator's awesome. All right, so then for side B, if I look at 18, B is the opposite leg. So I need the opposite leg. I have the hypotenuse. So opposite and hypotenuse is sine. So now I'm going to say the sine of 18 equals B over 24. So if I multiply both sides by 24, so now in my calculator, I need to do 24 times the sine of 18. So 24 times 18 sine equals 7.4. And I was also asked to do number 8. And then I'm also going to do either 9 or 10, since those are the ones where you're given the two sides. Okay, so number 8, angle B is 24 degrees. Side C is 10.8. Okay. Oh, and the other thing is, if you're setting these up correctly and you're following the steps on the calculator correctly, but you're getting the wrong answer, it's probably because you're in the wrong mode. Remember I said there's different modes, and you're probably in radians or gradians when you need to be in degrees. So that's the other issue, is I've had some people doing it correctly, but they're not in the right mode, so they get the wrong answer. So if you think that's a problem, just ask me and I will help you figure out how to get your calculator into the right mode. All right, so again, A is 90 minus 24, which is going to be 66 degrees. So looking for side A, well, A is the adjacent leg, and I have the hypotenuse, so that's cosine. So cosine 24 equals A over 10.8. So then I multiply both sides by 10.8. And so I'm going to plug that into my calculator. 10.8 times 24 cosine equals 9.9. Then for side B, well, if I look at the 24, B is the opposite leg. 10.8 is the hypotenuse. So I'm going to use sine. Sine is opposite over hypotenuse. So sine 24 equals B over 10.8. Multiply both sides by 10.8. So I need to do 10.8 times the sine of 24. So 10.8 times 24 sine equals 4.4. And remember again, I'm focusing on the SOHCAHTOA since that's the new part. Once you got the 9.9, if you did Pythagorean theorem to get side B, that would be fine. Okay, so once you have two sides, if you use SOHCAHTOA, that's great. If you use, one or the other, if you use Pythagorean theorem, that's great. Any of the methods. Okay, so let's look at number 10. And this is important because this uses the inverse. This is the one where you use it to get the angle. Okay, so remember, sine, cosine, tangent are when you're finding a missing side. Sine inverse, cosine inverse, tangent inverse are when you're finding a missing angle. So for number 10, we have A is 6 and B is 10. Okay. All right, so I need to find both angles and side C. So for angle A, 6 is the opposite leg, 10 is the adjacent leg. So I'm going to say sine A equals 6 over 10. So to get to the angle, I have to do the inverse. Sine, tangent, someone speak up. Wow. Why did I write sine? Opposite over adjacent is tangent. Opposite over adjacent is tangent. Sorry about that. Tangent A equals 6 over 10. So A is the tangent inverse of 6 over 10. So for tangent inverse, if you have a calculator that has a fraction key, you can just actually enter 6 over 10. A lot of times it's hard to find the fraction key, so I just say 6 divided by 10 equals tangent inverse, not tangent. So the inverse is the one where you have to hit the shift key or the second key first. So I'm going to hit second. Now it says tangent with the little -1. That's tangent inverse. And we get basically 31 degrees. So A is 31 degrees. Now to get angle B, I could just subtract from 90. But I want to practice this again using the calculator. So I'm going to use SOHCAHTOA instead of just subtracting from 90. Okay. All right, so for angle B, 10 is the opposite leg, where 6 is the adjacent leg. So tangent B equals 10 over 6 instead of 6 over 10. So B equals the tangent inverse of 10 over 6. So my calculator, I'm going to do 10 divided by 6 equals, and tangent inverse, 59 degrees. And check, 31 plus 59 is 90 degrees. So the two acute angles add up to 90. And just because I've been doing SOHCAHTOA everywhere else, okay, yeah, when you're doing the inverse, don't hit the equal sign because the equal sign is now adding on another. As soon as you hit the sine inverse, cosine inverse, or tangent inverse, it gives you the answer. If you hit equals, you're telling the calculator to do another one and another one. So you're going to just basically continue doing operations by continuing. So yeah, on the inverse ones, As soon as you hit the inverse, you're done. You don't hit the equal sign. So yeah, I know that's where it's a little confusing using the phone calculators. The newer calculators are nicer because you write it in the exact way it's written, and then you just hit equals and you're done. So yeah. Okay, so to get the hypotenuse, I'm just gonna, let's just do Pythagorean theorem. 6 squared plus 10 squared equals c squared. So 136 equals c squared. So c equals the square root of 136. And if you do Pythagorean theorem, you don't have to change it to a decimal. You can just leave it as the square root of 136. If you plug it into your calculator and change it to a decimal, that's fine. That's your choice. But yeah, if it's Pythagorean theorem, you can just leave it. All right, so how are we doing? Any other questions? All right, so on the phone calculator, down here on the bottom left, it says rad. That's what you want it to say. You want it to say RAD because that's not telling you what mode it's in. That's telling you the mode you want to pick. So if it says rad and you pick it, you've now switched to radian mode. So now it says DEG down here, and that's what you want. So we want it to